Thank you very much. And it's a delight to be here. I want to start by remembering a Jesuit for whom I'm very much indebted, the late Father Bill Stager, who died 10 years ago in March. He was both a Jesuit priest and a tremendous theologian and a scientist. He did his doctoral work at Cambridge with Sir Martin Rees, working alongside Stephen Hawking and others. He could work on the mathematics of the Big Bang and also give retreats to nuns, which I don't know which is the more difficult thing to be able to do. And if you find any wisdom in this talk, I probably stole it from him. But he comes to mind because I want to start with a wonderfully provocative quote from Stephen Hawking. It goes, "Because there is a law such as gravity, the universe can and will create itself from nothing. Spontaneous creation is the reason there is something instead of nothing, why the universe exists, why we exist. It is not necessary to invoke God to light the blue touch paper and set the universe going." And that was what they put out when the book came out in 2010, because, of course, they wanted to sell a lot of books. You'll notice that he had a co-author, Leonard Latimer, whose name you can barely see on the cover underneath his name in much larger letters. But it was a very successful book, a very provocative thing to say, kind of what you would expect from those British new atheists. And if he's allowed to say such an outrageous statement, let me counter with an even more outrageous statement as a scientist and as a Jesuit. He's right. You don't need to invoke God to start the universe off. In fact, you shouldn't. But to appreciate what he's saying and what I'm saying, I think it's worth taking an excursion into the physics that Hawking and Latimer were talking about and the bigger history of how we understand how the universe began. What we're talking about is something called cosmology, which is a word that means literally words about the universe. It was invented by a German philosopher in the 1700s, Christian Wolff. And he wanted a metaphysics about the metaphysics. He wanted to be able to say, how can we describe how the universe exists in terms of logic and reason? More generally, it refers to the kind of world picture or the culture or the school of thought that we have. If you're into the computer world, it's kind of the operating system that each of us has in our own brain, so that when we see things, we have already a way to interpret what it is we're seeing, which allows us to see just a corner of something and say, okay, I know what he's talking about. It is the sum of the assumptions that we make about how the universe is going to behave, and then what you can deduce from those assumptions. And it comes out of every school of thought, every culture. Often those assumptions are not even spoken. Sometimes we make those assumptions without even realizing we're making the assumptions. Now, the term cosmology was taken over about 100 years ago by the physicists and the astronomers to describe a scientific view of the origin and nature of the physical universe. But it can involve things well beyond what physics and astronomy talks about. And these non-physical cosmologies can play an important role in how we decide what questions are worth asking and what kind of answers are suitable answers. We start with an ancient cosmology. This is the way that the universe appeared to the ancient Babylonians and the way you find it described in Genesis. In fact, I swiped this picture from a theologian in England who uses it in her talks all the time, Paula Gooding. And basically it shows a dome in the midst of waters, separating the waters above and the land below. And a lot of cultures start with this because this is the universe you see when you look out the window. The sky comes all the way down to the horizon. The horizon is in a flat area. And if you look at night, you will see different things in the sky moving one in front of another. So there are, in fact, a series of these domes, a different dome for every planet in the sky. Those are the things that wander in amongst the stars. And the word planet comes from wanderer. I remember once I was talking to a group of Native Americans in Wisconsin, and I, talking about my field of meteorites, and I said, well, meteorites are rocks that fall from the sky. And one of the older women raises her hand and goes, which sky? Which means that their cosmology was the same as the cosmology of the ancient Greeks and the ancient Babylonians, where every planet had its own sky. In essence, she's asking, what planets do they come from? Which is the same questions we're asking. But in the next century after Genesis was written, the Greek philosophers like Parmenides and Pythagoras and Plato started arguing more about the nature of the Earth. They recognized that the Earth was a sphere. They recognized that the planets and the moon and the sun are bodies that move above the Earth and in front of the stars. And you can see that yourself. You can see the planets and the moon blotting out stars, and you can see the shadow of the Earth being round on the moon as it's full, as it's the opposite side of the Earth from the sun, and we have a lunar eclipse. And there are lots of other arguments that they had to not only say that the Earth was round, but even to be able to measure how big the Earth was. And they got it right. They knew what they were talking about. But as a result, the dome covering the Earth came to be understood as a shell surrounding the Earth. And then there's going to be a different shell, a different sphere, one for each of the planets. On total, there were 7 things in the sky that moved different from the stars, and that's where we get the 7 days of the week. Not only is 7 a magic number, but for mathematical reasons, but even today in English, we talk about Saturn Day and Sunday and Moon Day, and the other days of the week in languages like Italian are the other planets. So there's Marte Day, Mars Day, Mercoledì, Mercury Day, Jovedi, Jupiter Day, and Venerdì, Venus Day. In English, Tus and Woden and Thor and Frida were just the Norse versions of the same gods. The more interesting thing you notice, though, when you watch the motions of those planets is that they don't move in a smooth or particularly predictable way. And this image shows the position of Mars in 10-day intervals over a period of several months. And you can see it actually starts from the right, heads to the left, and then it loops around and goes backwards for a while, and then it loops around, and it's not only moving not in a constant rate, but not even in a constant direction. So how do you explain that with your spheres? Well, Eudoxus came up with the idea that the sphere that contains the planet is embedded in another sphere with axes in a different place embedded in another sphere, and each of these spheres are moving at their own rates. And in this way, you might be able to imitate the motion of the planets. This was, at the height of Greek philosophy in the year 300, 400 before Christ. At the same time, they're arguing about the whole nature of the universe beyond just where are the planets and how do they move. Plato talks about, is the universe internal? Was it always in existence? Did it have a starting point? He says, all tangible things are in the process of being created. Parmenides argued, on the other hand, that the universe was eternal. And then there was the mathematical side of cosmology. If you actually wanted to predict where the planets were going to be, because you believed in astrology and you thought that the positions of the planets are going to tell you when there's going to be wars and when there's going to be good crops, and you want to know where to invest your money, it would be useful to be able to predict the planets in the future. And the Roman-era astronomer Ptolemy, about the year 150, came up with a way of calculating the motions of planets by assuming, rather than interlocking crystalline spheres, that they moved in circles around the Earth, but within a circle there was a little circular motion, and within that circular motion there might be another circular motion, and if you have enough of these circular motions, you can match the actual positions of the planets. With this system, he could reproduce the observed motions of the sun and the moon and the planets. It was very accurate. He had a theory. The theory matched the data. Therefore, the theory must be true, right? That's a common logical fallacy that infects all of science. And we'll come back to that. Notice that that system is completely different from the flat earth with the dome separating the waters above and below that you find in Genesis. St. Augustine wrote a book on the literal interpretation of Genesis, where he writes, even a non-Christian knows something about the earth, the heavens, and the other elements of the world, about the motion and the orbits of the stars and their sizes and their relative positions, about the predictable eclipses of the sun and the moon, and the cycles of the year and the seasons. And this knowledge is known as held to be certain from reason and from experience. And it is, says Augustine, it is a disgraceful and dangerous thing for an infidel to hear a Christian, presumably giving the meaning of Holy Scripture, talking nonsense on these topics. Notice the irony, though. The knowledge that people hold to be certain from reason and experience is the cosmology that nobody today believes anymore. From this, you get the idea that Augustine was running into biblical literalists, even in his day. But for most theologians, this new cosmology didn't lead to some sort of Galileo crisis. They didn't say, oh my gosh, this is different from the Bible, therefore what are we going to do? Instead, they saw in this cosmology a reflection of the non-physical universe. They believed that the physical universe mirrored the spiritual universe. And they talked about a chain of creation with different levels or aspects of the physical universe. And each level, each of those spheres, if you will, was assigned to a different deity or a different god, or in the medieval days, a different rank of angels. Remember the ranks of angels? Anybody talk about the ranks of angels anymore? You've got angels, and then archangels, and then virtues and powers and dominions and thrones and cherubim and seraphim. I only know because I looked it up on the internet. In the Middle Ages, these were often identified with each of the spheres of the 7 planets and then the spinning sphere of the stars. These angels were only a small fraction of the invisible populations that inhabited that vast universe overhead. Because if something is moving, it must be alive or have something alive that's moving it. And therefore you had these intelligences, these planetary intelligences moving the different bodies back and forth. And if the word planetary intelligence rings a bell, that may be because you read some of C.S. Lewis's science fiction, where he takes this idea and has great fun with it. A key thing to remember, by the way, is these planetary intelligences are discussed in Scripture. When you hear the names of the words thrones and principalities and dominions, they're not talking about earthly dominions, they're talking about these creatures in space. An example is Paul in the letter to Colossians. He speaks of Jesus as the image of the unseen God, the firstborn of all creation. In him were created all things on heaven and on earth, everything visible, everything invisible, thrones, ruling forces, sovereignties, powers. His point is that he's talking to a culture that has a cosmology that believes that there are these powers overhead, and they've got good reason to believe. You can see the planets. You can see if they're moving. Whatever it is that's moving those planets are these powers and thrones. And your astrology said that was what's sending down little geniuses of whatever they were specializing in. And by golly, I've got to be worried about making sure that they're well taken care of. And Paul is saying, no, they are not gods to be worshipped. Jesus is the one who created whatever is out there in space. The Creator working through Jesus, the image of the unseen God, the firstborn of creation, in whom were created all things on heaven and earth. That essential division between the created things and the creator is something we're going to come back to. I'd mentioned C.S. Lewis. Lewis, as you may know, had a day job besides writing fantasy and science fiction. He was a professor of medieval and Renaissance literature, first at Oxford and then at Cambridge. And he knew that you had to be able to explain these things in order to explain the literature that you're reading. If you're going to read Dante, you have to know the cosmology that Dante is assuming everybody who reads him is working under. If you're going to read Chaucer, you have to know what are the things that Chaucer is assuming all of his readers would assume the universe had. The assumption is if something's moving, then it's alive, it has a spiritual entity. The medievals proposed that they were the motions of the intelligences, the planetary intelligences, were an intellectual love of God. Love makes the world go round is not just a pop song. It was part of that medieval cosmology. And anybody for themselves could see that they existed, because you could see the planets move. The heavens moved without fail in a continual and a predictable way, and that's the realm of the angels. Out beyond, in the fixed abode inside which they moved, is where God lived. Of course, they're eternal and perfect. By contrast, here down on earth, there must be a different kind of physics, because things wear out and die. And that's just evidence of original sin. This corrupt physics describes everything below the moon. And below that is the inferno of hell. And you know that hell is below the earth because I can show you a mountain in Italy where you can look in and see the fire and brimstone, power coming out of the mountain. Again, something you could see for yourself. Notice that in this cosmology, the earth is not the center of the universe. The earth is the bottom of the universe, only one level removed from the inferno and subject to laws of corruption and death. A lot of people misunderstand this. The centrality of the earth is not that it was a special place, but just that it's the only place. One of those assumptions that was so obvious, nobody bothered to spell it out. In this discarded image, C.S. Lewis writes that actually this idea of the universe with hell at the center and God at the most extreme really is a human inversion of reality. If we could but see the universe correctly, God is at the center, surrounded by all the angels, and we humans are at the farthest reaches of creation, the most removed from God. It's also important to remember that when they're talking about the earth at the center and the sun and the planets are going around the earth, that's not the same thing as us thinking that the moon with all its craters is moving past and Saturn with all its rings. Earth and moon and Saturn are something fundamentally different from what Earth is. Because the cosmology is not just how the pieces are arranged. It's about the very nature of the pieces themselves. Out beyond the lunar sphere, the translunarian spheres, matter is of some kind of quintessence, which we do not experience and couldn't possibly understand. All of this cosmology can be demonstrated by observations. You don't need telescopes, you don't need special skill, you don't need mathematics. Anybody could see it for themselves. And it was a beautiful system that underlay not only the physics and astronomy, but the music and the literature. And anyone who was educated would be educated in this kind of cosmology. It was a common sense view of the universe that was so widely accepted, people didn't even realize they were accepting it. C.S. Lewis famously in his book writes, and if I can see if I can get here, few constructions of the imagination seem to me to have combined splendor, sobriety, and coherence in the same degree. It only had one defect. It wasn't true. But it was accepted for more than 1,500 years. This is the way people thought how the universe worked. That's what made the Copernican system so suspicious when it came along. He was superseding the mathematical cosmology of Ptolemy, and it had a new way of how the planets were arranged that was better than the old way. But also, it came up with a new idea of what those planets were. And that maybe the same physics applies to them as applies to us. I'll talk a little bit about the Copernican system, but there are 2 points in particular that I want to get clear. First of all, what was introduced in 1543 in Copernicus's book was definitely controversial. Some people called it foolish. Nobody called it heresy. It was published, dedicated to a pope, published at the urging of a cardinal. 1543 was just a couple of years before the Catholic Church opened up the Council of Trent. And for 18 years, the Catholics went around looking for heresy everywhere they could find it. And nobody bothered talking about Copernicus. It was not a topic. It was not considered heresy. The other misconception you can see in these 2 pictures. The picture on the left is the picture that's in the beginning of Copernicus's book, and I don't know if you've ever bothered taking a look at Scientific American, but most people who look at Scientific American, they'll read the title of the article, and they'll look at the pictures and maybe the figure captions. Few people actually bother to read the articles. And it was no different in Copernicus's time. People saw the picture, and they thought that's what he was proposing. But actually, what he was proposing is much more like that image on the right. He still had circles and circles within circles, and even the sun was doing a little circular dance around an imaginary point. And he had to have those in order to have the mathematics recover the actual observed positions of the planets. It was a little bit easier. There was one less layer of calculation you had to use by having the Earth go around the sun rather than the other way. But it wasn't that marvelously simple view of the universe. There's another thing that's worth noting. At the time of Copernicus, there were ways to test, is the Earth moving or not? The Danish astronomer of the next generation, Tycho Brahe, greatly admired Copernicus, but he looked at the positions of stars, bright stars and dim stars, and he never saw them move. In other words, let's say the Earth is actually moving around the sun, and it goes from there to there. As it moves, the relative position of the close star to background stars will move to a different set of background stars. If stars are at different distances, you ought to be able to see that relative motion. Let's assume all stars are the same, and let's assume all stars are just like the sun. And that would mean that the brighter stars must be closer than the more distant stars. So you ought to be able to see this difference. If you look at a star in a telescope, it looks like a disk. If you assume that disk is the size of the star, and you calculate how big that disk is that you see in the telescope compared to the size of the sun, then you calculate that the stars must be really close to us, and you should be able to see this parallax. And nobody ever saw it. And there were 3 or 4 other really good scientific observational arguments against the Copernican system. Tycho Brahe came up with his own very clever way of doing things. He said, we'll keep the Earth in the center, we'll let the sun go around the Earth and all the other planets go around the sun. This gives us all of the advantages of the Copernican system and allows the stars to be standing still. Kepler, on the statue next to Tycho Brahe, was a generation later. He inherited Tycho's data. And he was also one of these transitional characters where he still thought the shape of the physical universe mirrored the shape of the metaphysical universe. So you've got a system where the sun's at the center of the universe, the Earth goes around it. He didn't like that idea of the sun making a little circular dance. Why? because unlike most of the other theologians of his day, his mysticism told him that the Son, S-U-N, was actually God the Father. And the light coming off of the Son was the Holy Spirit. And you couldn't have God the Father making this goofy little circular motion around nothing. That would be highly unlikely. So instead, he fixed the system by having the planets move in ellipses around a focus. And you could put the Sun at a focus, and there'd be nothing at the other focus, but we won't ask what that's supposed to mean. And in this way, he could match the positions of the planets. And we have letters to his friends where he's explaining all of this. A book by Job Karansaram on the discovery of Kepler's laws quotes, "The center is the origin and the beginning of the sphere. The origin has precedence everywhere. When we apply this consideration to the Holy Trinity, the center refers to the image of God the Father. So it should be adorned by the most ornate body, that is the sun." He came up with elliptical orbits not because it was simpler, not because it gave better results, but because it matched his own metaphysics. Even in his time, Kepler's theology was considered to be ridiculous. And it was so crazy, and his Latin was so turgid that most people actually didn't even pay attention to him. Galileo had a copy of Kepler's book describing the elliptical orbits, and as far as we can tell, he never read it. Kepler's Latin was turgid, and Galileo's Latin was weak, so I can understand why he wouldn't go into it. But a generation later, Isaac Newton used these elliptical orbits. Isaac Newton, a generation later, comes up with the idea of a set of physics that works both in the heavens and on the earth. If you get rid of friction and other things that make things seem to slow down on Earth, they would continue to move forever just like they do in space. And that's Newton's first law. If you do change it, then you must have a force, an outside force, to cause something to speed up or to slow down or to move in a circle. That's Newton's second law. And whatever is causing the one thing to move has a reaction force on the thing being moved. Newton's third law. It predicted, and then he came up with a law of gravity that predicted, when you do the math, that planets move in ellipses, just like Kepler had shown. Notice what this means. If the same laws apply everywhere, then there's no difference between the heavens and the earth. The old cosmology is out. It has to be replaced with a new cosmology. And the main principle is that if every place follows the same laws of physics, then there is no special or privileged location in space, nor is there any spot that's the most unprivileged, the sump of the universe. Love is no longer causing the earth to move or the planets to spin. The force that explains and controls the motions of the planets is the same force that causes an apple to fall. That's gravity. I can use these laws to describe how gravity should behave, and I can calculate moment to moment where the falling apple or the orbiting moon ought to be. He did notice certain gaps in his theories, though. For instance, if the sun controls the motions of the planets by pulling on them with gravity, and the gravity comes because the sun has one mass and the planet has a different mass, shouldn't the planets also be pulling on each other? And shouldn't that cause the whole system to fall apart? And his answer is, yeah, but I guess God makes sure that doesn't happen. Therefore, I've just proved that God exists, because otherwise, why would the planets be in stable orbits? There is another question which he doesn't address. Where did all the suns and planets come from in the first place? Plato argued that there was a prime mover as the source of all motion, and medieval theologians said, oh, Plato was obviously talking about God the Creator. And Newton said, oh, that works for me too. God could be the thing who set up the system and starts it moving, but then, once the universe is in motion, its laws inexorably describe everything that happens next. Obviously, you're going to need a creator God to set things up. But there's no need in this cosmology to have a personal God who intervenes in nature once it's been set in motion, except to, correct things that weren't quite right. And this is the source of the medieval idea of deism. To the deists, God is the great clockmaker. He designs and he assembles the gears of the universe, he winds it up, sets it going, and then does nothing more except maybe, change the watch to keep it up on time, reset the positions of the planets. And that was the state of cosmology after Newton. Incidentally, in the 100 years or so after Newton, a lot of the arguments against the Copernican system were finally resolved. Eventually, we realized that the disks that you see in a telescope are not the disk of the sun, but the wave nature of light being made manifest in a way that nobody could have expected. And I won't, you want me to go into that? It's another half hour of explanation, but I can do that with this very simple, never mind. There is another difficulty with Newtonian physics, and one that I don't think gets enough attention except for those of us who have had to teach freshmen. The laws of physics depend on knowing the forces acting on the body, like gravity. If you have a position of the body and a mass of the body at a given time, then you can work out these strange and frankly unfamiliar notes. What happens when you're teaching freshman physics and you talk to them about mass and time and space? The first question I usually get is, well, what is mass? Well, mass is kind of the amount of stuff. Yeah, but what is stuff? Well, it's stuff that's made out of mass. You have to have an empirical axiomatic idea of mass, which is different from weight, because masses in space have no weight, but they have the same amount of mass. And it's different from density, because, as they say, a pound of feathers weighs as much as a pound of lead, but they obviously take up different spaces. And then you get the, and what is time? Time is the thing that you measure with a clock. Yeah, but what is it actually measuring? And only when you're advanced do you realize that our idea of space is likewise axiomatic. What do I mean, this position relative to what? And what is the fundamental thing against I'm measuring all the positions? Because you just told me that there is no special place against which I can measure all the positions. That's what makes Newtonian physics strange and difficult and so hard to teach to freshmen, including me when I was a freshman. I nearly flunked it the first time. And the way eventually we teach students to understand Newtonian physics is essentially, though we don't put it in so many words, we paraphrase what John von Neumann, the mathematician, said about mathematics. You never really understand physics, you just get used to it. And the way you get used to it is by doing all those problems and getting the answers in the back of the book. As you can see, there's something at the end of this which is unsatisfying, even though it works so you can build bridges that don't fall down and airplanes that fly. And then there's modern cosmology that came up in the last 100 years, relativity and quantum mechanics. Among other things, quantum mechanics says that there's a fundamental uncertainty or fuzziness. You can't give a precise location to anything because at the quantum level there is no such thing as a precise location. After all, what is location? Don't ask. And it's not just because we're not clever enough to measure it, it's because fundamentally we're trying to measure something that doesn't exist. Space and time are fuzzy. And relativity is even worse. The first part was special relativity, looked at the special case of a system coasting along with no outside forces acting to change or accelerate it. And even in this simplified system, Einstein shows that a lot of the things we take for granted as common sense, the measure of mass and space and time, depend on the frame of reference you are in when you make the measurements, so that time moves differently on the moving spaceship compared to the guy waiting back home for his twin to come back from Alpha Centauri. Einstein's theory was even more shocking than Copernicus's theory, because it shows that the hard-won understandings of Newtonian physics that we work so hard to finally make our common sense, guess what? They're not right. They're not completely true. They'd worked for 300 years, but throw them out the window. And we're not even going to go into what happens when you try to combine quantum physics with this. Special relativity, why, if it's so weird and it's so crazy, why would we believe in it? Because only it can explain all sorts of things that we were beginning to measure by the early 20th century. It gave us the famous E equals mc squared measurement, calculation equation that shows how you can turn mass into energy, which explains how stars shine, and is used to make bombs. It explains how a magnetic field is just the relativistic expression of the electric force. It's a mathematically elegant theory, and it works. So it must be true. You can hear Ptolemy laughing in the background. General relativity is even weirder. Isaac Newton gave us this theory of gravity, but he never attempted to explain what gravity actually was. He just said, whatever it is, it follows my equations. If you look at the last page of his Principia, you find this marvelous phrase when he comes up with what is gravity? Hypothesis non fingo. I feign no hypothesis. I'm not even trying to guess what gravity is. All I know is that I see it, and it's working. Einstein did feign a hypothesis. His general relativity said that what we call mass can be thought of as a warping of the geometry of space-time. And so not only does time become part of space, which he needed to be able to have time and space look different from different frames of reference, but if you have an acceleration like gravity, space and time itself can be warped. And it can be warped in a predictable way. So something that thinks it's moving in a straight line actually moves in a curve because the thing that it's moving through has been bent by the presence of what we're calling mass. Among the things that would be bent are light rays. So if you have the sun, the light of a star behind the sun as it passes close to the sun will be bent a little bit out of where it appears if there was no sun in the way. How can you see a star right next to the sun? Wait for an eclipse. And in 1919, Sir Arthur Eddington observed the slight shift in the apparent position of a star during an eclipse. And it agreed with Einstein's theory. It disagreed with other proposed theories. The general theory of relativity had passed a significant test. Most of you have heard of Einstein, right? Most of you know what he looks like. Most of you know that if you want a stereotyped comic view of a genius, they'll have wild frizzy hair and a thick German accent. Where did that come from? Why is it, of all of the people who were doing great science 100 years ago, everybody knows Einstein, hardly anybody knows Schrodinger except for that stupid cat, or Niels Bohr? Why is Einstein? The answer is this article, which appeared in the New York Times. The New York Times was told that Dr. Eddington was going to have a press conference, and they didn't have a reporter available in London at the time, but they did have a sports reporter who was there to report on a golf tournament. So he shows up and he reports the scientific evidence as if it was a golf tournament with winners and losers. And all of the cliches that you've ever heard about relativity, Einstein's theory triumphs. The star is not where they seem to be, but don't worry. It's a book that only 12 wise men could understand. I remember hearing this garbage when I was, in grade school 50 years later. No more in all the world can comprehend it, said Einstein, when his daring publishers accepted it. Crazy. There were other bright people. The guy with the pipe there, that's Arthur Eddington. The guy with the familiar-looking collar was a guy named Georges Lemaitre. Now, Georges Lemaitre was a Belgian with a PhD in mathematics from Louvain and a PhD in astrophysics from MIT, though he had worked at Harvard. Harvard didn't give degrees in those days, so in astrophysics. And he was interested in this interesting problem. If mass is a warping of space and time, eventually the warping of space and time should cause all of the universe to warp itself together into one ginormous mass. In other words, if everything has gravity, how come the entire universe hasn't collapsed into one point? Well, it'll take a long time, but if you've got an infinite universe, you've got all the time in the world. Why didn't it happen? A fellow named Alexander Friedman in Russia said, well, maybe the universe has some kind of expansion term in it which counters this gravity. We don't know what it is. It's just a magic term that holds things up. Georges Lemaitre organizes this into an idea. Maybe the universe has built into it an expansion. Maybe there is something, if everything in the universe is moving away from everything else, at that point, they had seen that galaxies were moving away from each other. We could see the redshift, but nobody had worked out a system behind it. Lemaitre suggested, maybe if we measure the speed of the galaxy, it will be proportional to the distance from us, which is what you would expect if all of the galaxies in the universe started out at one point and were expanding away, like a giant explosion. He called this the primeval atom. So he's the guy in the front with the collar. The guy in the back with the circle is Fred Hoyle, who believed in a very different system. He thought that the universe was expanding because there was new material constantly being created, and therefore whatever you see at the universe now is the same as the universe you would have seen a billion years ago, or 10 billion years ago, or 100 billion years ago. And he so disliked Lemaitre's theory that he went on the BBC and he made fun of it. He said, that Dr. Lemaitre's Big Bang theory. That's where the name comes from. One of the reasons Hoyle didn't like the Big Bang is because it suggested a creation point, and the guy who happened to come up with it, that Georges Lemaitre, happened to be a Catholic priest. Obviously, he's just trying to recover Genesis. He's not the only one who made that connection. Pope Pius XII, speaking to the Pontifical Academy of Sciences, says, isn't it interesting? Scientists are talking about the universe having a beginning. We could have told them that. Lemaitre himself went to the Pope and said, no, don't do that. Don't make that connection. In the years since then, all of the evidence, the testable evidence, is on the side of the Big Bang. Fred Hoyle himself, who became great friends with Georges Lemaitre, by the way, actually eventually admitted, yes, the Big Bang happened. There's the primordial abundances of hydrogen and helium, the 3-degree background microwave radiation, lots of other lines of evidence independently say, yes, the universe is expanding. The populations of stars, the fact that older stars have a different chemical composition from younger stars means that the chemical evolution of the universe can be seen in the stars we're observing. We can look at stuff from the past, and it tells us the universe in the past was very different from the universe today in the way that the Big Bang predicts. So that brings us back to Stephen Hawking and the primeval atom. For a lot of years, Hawking's been working on this theory that maybe quantum fluctuations, that fuzziness, in the space-time continuum, that thing from relativity, could provide a setting that by chance would give rise to the singularity of space-time that looks like the Big Bang. If you have an infinite amount of time, the quantum uncertainty is mostly really small, but some of them are bigger and some of them are bigger yet. And maybe with all of the time in the universe, one of those fluctuations would be so big that it becomes the Big Bang. Maybe. But he's making the same mistake. He's equating the thing that started the Big Bang with God. And he's saying, because it will do it itself, I don't need a God. Actually, what he's saying is that gravity is what starts the Big Bang. And if he's saying whatever it is that started the Big Bang is what I will call God, and that gravity is the thing that caused the Big Bang, therefore it logically follows that God is gravity. Maybe he thinks that's why Catholics celebrate Mass. Okay. Gravity is not God. But invoking a God to do something in the physical world that I can't figure out how to do otherwise is the God of the gaps. The same God as Newton invoked to try to explain why the planets don't interfere with each other, when it turns out in our solar system the planets are far enough away from each other that those fluctuations are relatively negligible nowadays. In fact, were less than negligible in the years past. And of all the 5,000 other solar systems we've seen, we actually do see the planets interfering with each other the way that Newton was afraid they were going to. He had invoked God to fill in the gap, which actually turns out to be just a pleasant coincidence of the solar system we're in. Newton thought that he could use his physics to prove the existence of a God, but the God he was invoking was just another law or force in physics, in nature. And the danger of depending on a God who is the God of the gaps, if I believed in God because I didn't know otherwise how the Big Bang could have occurred, and Stephen Hawking comes along and says, guess what, I can explain it with a quantum fluctuation of the space-time continuum. Doesn't that really sound great? I'm not quite sure what a quantum fluctuation or space-time continuum really is, but then I don't know what mass and space and time are either, so never mind. But if you could convince me that the universe could make itself, and that was my reason for believing in God, then I would have no further reason to believe in God. The Jesuit theologian Michael Buckley wrote a book on the origin of modern atheism, and he argues that it was the deist picture of the God of the gaps that led to atheism. All the reasons that they had come up with to believe in God were gods of the gaps, and as the gaps were closed, then that God was no longer necessary, because it was the wrong picture of God. It's also important to remember that that watchmaker God, that God of the gaps, that God who would start off the Big Bang, is not the personal God of Scripture. But then Newton's understanding of a completely deterministic universe had already done away with free will. That kind of deism had done away with transcendent experiences such as justice or beauty or love. Newton had confined himself to the things that could be measured. If you can't measure it, it doesn't exist. How do you measure beauty? You know what a millihelen is? Milli meaning 1,000th. A millihelen is the amount of beauty necessary to launch one ship. Since Helen had the face that launched 1,000 ships, never mind. I've got to quit with these jokes, I know. That mechanistic and deistic universe is a meaningless universe. It is a universe that has no freedom, it has no beauty, it has no meaning. This Nobel Prize cosmologist Steven Weinberg famously said, "The more the universe seems to be comprehensible, the more it seems to be pointless." And Bertrand Russell spoke of building a philosophy on the firm foundation of undying despair. How cheerful. But there's nothing new in that idea. If you've read the book of Ecclesiastes, vanity of vanities, all is vanity, the Rabbi Sachs has retranslated that. Meaningless, meaningless, says the teacher, utterly meaningless. Everything is meaningless. Man's fate is like that of the animals. The same fate awaits both. As one dies, so has the other. They have the same breath. Man has no advantage over the animal. Everything is meaningless. In other words, that's not something that came out of Weinberg's modern science. He didn't have to come up with a better and closer understanding of the universe. It was already in Scripture 2,500 years ago. That view is perfectly self-consistent and philosophically naive. Because the whole genius of the God of Abraham, as Rabbi Sachs points out, is that God is supernatural. A God beyond the universe. The gods of paganism were inside the universe. They were throwing lightning bolts. Maybe they lived longer, but they were still part of the universe. But nothing within the universe can give rise to the universe. It's a contradiction of terms. Nor could they give meaning to it. And Sachs cites Wittgenstein, the sense of the world must lie outside the world. He gives the example of a chair. A chair has meaning only if there's something not a chair sitting in the chair. The universe has meaning only if there is something that's not part of the universe to which the universe has meaning. That's a very different picture of God than the God who's just around, lighting blue touch papers and starting universes off. It's essential that you recognize the God it is you're trying to find. A God of beauty and joy and love, the way, the truth, the life. These are attributes that can't be derived by scientific analysis. They can only be experienced. And only such a supernatural God gives life meaning. Only a supernatural God existing outside of the mechanism of Newton's universe can account for us experiencing beauty and freedom and love. And the laws of nature, which not only work, but also are beautiful. And that's why there's something instead of nothing. There's another caveat to what Hawking was saying. Not to invalidate his point. His physics is fine as far as I can tell. But we recognize, for instance, that what Ptolemy was doing with calculating planetary orbits, we can do better than that. It took 1,500 years, but we did better than that. Likewise, Hawking's conception of spontaneous creation probably will be superseded. In the 25th century, cosmology is going to look just as quaint as spontaneous generation looks to us. In fact, that's what I hope so. If you write a scientific paper that's never shown to be incomplete, that means nobody's ever bothered to read it. The whole point of how science develops itself is by constantly improving, constantly getting better. If you're trying to base your theology on the best physics of 2024, by 2034, you're going to be looking at stuff that looks ludicrous. Every good cosmologist has to be humble about cosmology. We all know that, like every scientific theory, it's going to be developed further. At some future date, even the Big Bang could be replaced by a theory that fits the data better, or better yet, answers questions we haven't even thought to ask yet. It's not like we're going to find out that everything's wrong. More likely, you're going to find out that everything was right as far as it went, but there was this other thing going on that we hadn't noticed at the time. Just as, for good reasons, people thought Copernicus was wrong, until you realized, oh, wait a minute, the evidence we're looking at is flawed in this way that none of us realized. Contemporary cosmology with all its limitations. That's our contemporary common view of the universe. And it's kind of scary if you're a physicist now. Every physicist still starts out learning Newtonian physics, struggling with it for 3 years. Finally, it makes sense, and then you get to relativity and you find out it's all wrong. But it still is the basis of a lot of the common sense we use when we guess how we're going to think about the universe. Maybe we'll come up with a different way of teaching physics so that space and time can have a meaning intuitively to students different from what the intuitive meaning is to us. And we'll use words like space and time the way we use words like epicycles, still assuming, of course, that being brilliant means that you have wild hair and a German accent. One thing you do take from this is that even our current common sense understanding of how the universe behaves is a woefully incomplete picture of physical reality. And every advance causes us to appreciate both the complexity and the beauty of the universe. We can't even think about the universe without using terms and images that are poetically metaphors for something we otherwise can't wrap our brains around, except by getting used to them. But it's interesting to see how major religions adapt in the face of all the changes that we've had in cultural cosmologies. It turns out, I believe, certainly in the case of Christianity, that a good religion will be strengthened by having a shift in its assumptions. That's where you find out what is essential and what is cultural baggage. The physical cosmology of Genesis is dead, but the essential message is that regardless of how we think the universe was put together, nonetheless, God was already there before there was a universe, hence God outside the universe, supernatural. God intends the universe to exist. It's not an accident. God creates a universe as logical as day follows night, and God looks at the universe and says it is good, and the goodness of God can be found by studying the universe. And that stays true regardless of what cosmology you're working on. Our cosmologies change, but our big questions remain. Who are we? Where did we come from? What are we doing here? Science isn't going to answer those questions, but it can help illuminate the questions. Still, those are questions that can't be solved with an equation. They're mysteries for contemplation. And I want to just come back one last time to emphasize the point. That why is there something instead of nothing that Stephen Hawking talked about is actually quoting from a contemporary of Newton's, Gottfried Leibniz, wrote on the ultimate origin of things the question, why is there something instead of nothing? To ask why is there something is very different from asking what happened once things got started. Science can tell you what happened once things got started, but science doesn't tell you why there is a space-time continuum, why there is mass and space and time, why there are laws of physics. The idea of the universe created out of nothing has an interesting origin point. You find it in Aquinas, of course, creatio ex nihilo. And it's God not only creates out of nothing, but because time itself is created, that means that the act of creation occurs at all times and all places. God didn't create the universe 13.8 billion years ago, and wherever the Big Bang happened, God is creating the universe right here, right now, even as we speak. Aquinas talks about maintaining the universe. It's really what he means. The idea of creating out of nothing we find in Scripture in a very odd place. Second book of Maccabees. There's this mother, we don't even know her name, has 7 sons being tortured by King Antiochus. And she tells the youngest son to remain firm in your faith by reminding him, and I quote, "Look at the heaven and the earth and see everything that is in them and recognize that God did not make them out of things that existed." One of the most profound insights into the nature of reality, and it comes from a mom whose name we don't even know. We do have this to thank Hawking. As I say at the beginning, he was right. It's good to not think of God as the guy who starts off the blue touch paper. It's good to remember that our God is not the God of lightning. In fact, the ancient Romans accused the Christians of being the new atheists because they didn't believe in the God of lightning. They only believed in the supernatural God. We are almost atheists. I only believe in one more God than Stephen Hawking. But this God is not a force to be invoked to swell a progress, start a scene or two, to fill the gaps in our knowledge. It's the reason why existence exists. And I believe in that God not at the end of some logical chain of calculations, because trust me, I don't trust myself to be able to calculate that way. I believe in God not because I don't have any other explanation for how the universe came along. Somebody's going to come up with those. Stephen Hawking may be right. I believe in God because of the person of Jesus Christ in history, in Scripture, in my own personal prayer, in my own personal life. I have experienced those things that physics shows me but cannot explain: beauty and freedom and reason and love. A universe that exists is inexplicable. One that follows rational laws is impressive. One whose laws produce beauty. Who would expect that? The rational laws not only produce beauty, they are themselves beautiful. That's transcendent. I adore God not just because his universe exists, but because his universe is such a joy to play in. And that joy is what I call science. Thank you very much. And I'll point out that I'm here representing the Vatican Observatory Foundation. You want to know more about us, there's sign-up sheets in the back. And I've been told to read this to everybody. We are exploring the farthest reaches of creation, the galaxies, stars, planets. That takes money, your tax-deductible gift, provides a scientific study that helps us reveal God's unlimited majesty. There's a whole universe out there. Let's explore it together. Thanks a bunch.
Okay, Brother Guy. How can we distinguish, now let me start with this one. If Newton used God to span the gaps, don't theologians and preachers use poets? And secondly to that, how do we distinguish epistemology from cosmology?
The second one is a great question. I have no idea. But I think there's quite a bit of an overlap between the two. In the first one, I will answer by reminding you how much physics is poetry. Because poetry is using words in an unusual way to try to expose us to an idea or an experience that we might not have had. And all that physics can do is to use words or numbers or even equations. Every equation is like a sentence. X equals, well, X is the object and equals is the verb and so on. X is the subject. But Newton's law of physics is not, or law of gravity, is not gravity. Newton says the path of a falling object is like the solution to this equation. And that's the simile, right? Not metaphor. I always get metaphor and simile mixed up. It's poetry. Ultimately, everything is poetry. But we have a cosmology, an operating system built into ourselves that automatically translates that poetry into, I know what they're talking about. And an awful lot of learning a new language is learning what is the poetry and realizing there are new ways of saying the same thing, and sometimes they have ways of saying things that we don't have. The Italian language invented a wonderful word that we never got in English, after the moon landing, the allunaggio. Atterraggio means the landing, terra meaning earth, land. Allunaggio means landing on the moon, but the closest we could do in English would be the mooning of, has a very different meaning in English. So basically it is all poetry. But it's poetry to try to induce us up here in some way to understand a thing that in a way we hadn't understood it before.
Thank you. Thank you. Okay, are there any predictions able to be made about future laws present in the universe, akin to the gaps in Mendeleev's periodic table?
There are regularities that you look for, and we're at an interesting moment, I think, in quantum physics. There are probably people here who know this better than I. In atomic physics, the Higgs boson was sort of the last gap of the Mendeleev kind of table. We know there's something there, we don't know what it is, let's look for it, we found it. But it, of course, is just different enough from what they predicted that now they've got a whole bunch of new things to look for. We're never going to run out of such things. Likewise, in our understanding of astronomy, we have come to realize that the universe is not only expanding, but it seems to be accelerating. What is doing it? We don't know. Is it just that we got the law of physics and gravity wrong? Or is there another force? Is there something beyond the energy range we're able to measure? We don't know yet. We can see that the universe has mass which bends light in a way that says there is stuff there that we can't see. And that stuff doesn't behave in the way that massive stuff that we can see behaves. Two clouds of dark matter and matter run into each other, and the matter sort of collapses and hits each other, and the dark matter passes through each other. So it's something different from ordinary matter. And we know it's there, and we can see its effects on the things we can see, and we don't know what it is. So there's no shortage of fundamental puzzles about the universe that will keep the next several generations busy. And if they do their job right, they will create even more puzzles for us to think about.
This kind of follows within that. What do you think about the possible existence of life on other planets existing within another dimension?
Life on other planets, I will say I believe it's out there, with the emphasis on believe, because there's no data, except that there are other planets. I'm reminded of the wonderful Pogo cartoon years and years ago, where one character says to the other, some people are saying that human beings, some people say that there are creatures in space more intelligent than human beings, and other people say that human beings are the most intelligent creatures in space. And either way, it's a sobering thought. I don't know. And when it comes to other dimensions, I'm not quite sure what that would even mean. So I can't say no. The science fiction fan in me loves having that as an escape clause to come up with new and crazier views of the universe, as long as they make for fun stories. Who knows?
Do you think the planets were created at the same time? Is another Big Bang a possibility?
So you have to remember, planets are different from stars, stars are different from galaxies, galaxies. The sun is a star. Most stars are not like the sun, but the sun is a star. And the sun has these little bits of dust orbiting around it called planets. And compared to the size of the sun, the planets are minuscule. We now realize that most of the stars we've looked at and try to be able to find planets probably have planets. So that's very common. All of the stars that we can see in the local sky are orbiting around a common center, which is all inside our Milky Way galaxy. But there are other galaxies that look like ours or look different from ours, but are collections of stars. And they come in clusters. And then these clusters of galaxies come in large-scale structures in the universe. the whole universe itself appears to be expanding in such a way that it was all in the same place, but it is the space itself that is expanding. So it's not that there was this big explosion into empty space, but rather the space between the galaxies is growing bigger. Where space-time is this rubber-like stuff that can fluctuate oddly in space and time. And if you understand that, then I've done it wrong. But it does mean that the creation of the universe is different from even the formation of stars, which occur within the setting of the gas that ultimately was created when the universe was created. And planets are just these little bits of dust that happen to be left over after stars were formed.
Thank you. In your view, is the age of the universe significant to cosmology, or is it an academic frolic?
The measuring the age of the universe is significant because it's tied in with a lot of questions about the shape of space-time. Is space-time fundamentally curved, or is it flat? If the universe is expanding, will it eventually run into itself at the other end? Or does it actually expand out forever? And the measure of that, given the measure of other things, is all tied together in a set of equations that are coupled with each other so that knowing the age of the universe is one of the fundamental points that is tied into the expansion rate of the universe. So it's more than just an academic question, unless you think that the entire nature of space and time in the universe is an academic question, which of course, in one sense, it is. I don't need to know that to be able to answer what's for lunch. But I do want to be able to think about that if I want to be a creature that's interested in something more than just what's for lunch. And so in that sense, to be able to dream about what is this universe and how do I connect to it and how do I fit in with the creator of it all, that's a really, I think, important thing for any human being to be able to do. Some of us do it with science, some of us do it with writing poetry, some of us do it with dance. This is the thing that makes us more than just contented cats.
This question relates to what you just said. The questioner said, I explained to my daughter about the Big Bang matter did not expand, space expanded. Into what? She asked. Non-space? What is non-space?
The fact that she's puzzled means that she realizes there's more to it than what is simple. It is everything. One possible way to think of it is all of the space that we can see now was originally in a point. Maybe there was a point next to that other point which is also expanding. Only it is so far from us and expanding so fast that we don't have any causal relation to it. There's no way that what goes on there could ever affect us in a way that we would even notice it was there. The universe could be a whole lot bigger than what we're used to thinking about. There could be many more universes than what we're thinking about. The creator of all of them is the same God who invites us to call him Daddy. To me, that's a more astonishing thought than how big the universe is.
Very good, very good. Here's one on a different note. How does artificial intelligence play into the church's cosmology? And would you baptize a robot?
When I was at MIT more than 50 years ago, my roommate, a guy named Paul Mailman, math major, worked in the artificial intelligence laboratory and worked closely with Seymour Papert. I was part of the science fiction club where a buddy of mine was a woman named Margaret Minsky, whose dad was Marvin Minsky. These are some of the big names in AI. So I've been around this field for 50 years. They're really, really clever programmers. And AI is really, really clever programming, but it's a terrible name for what it does. What it actually does is all the hard work that we're too smart to do. In some ways, it's artificial stupidity. It doesn't get tired making and looking through all the possibilities that we would get bored trying to chase down one after another after another. It has nothing to do with intelligence. It's great stuff, but it's being horribly oversold. Young man, the young graduate that I'm speaking to here, I have one word for you. One word. AI. AI has become the plastics of our generation. I think most of the people here recognize and just like plastics, it can be poisonous. Just like plastics, it can stand for everything that's cheap and miserable. AI on your computer system and your search engines scrapes the internet for stuff and generates stuff that sounds reasonable, whether it's true or not, and then puts it on the internet for the next AI to scrape. So eventually it's poisoning itself. That said, could we eventually create a machine with intellect and free will? Maybe. If you had a machine that was self-aware and free to make choices, then it would be free to commit what we call sins, or free to do what we call love. And in a relationship with a universe of love and good, it might want to have some way of relating to that. Could a human being ever create such a thing? I am reminded of what I heard 50 years ago. The human baby has a brain that still, pound for pound, is more powerful than any mechanical computer, and it can be made by unskilled labor. We do create machines, biological machines that are capable of free will and capable of love. They're called babies. So, is it possible we could, create such other? I'm not worried about it. Just as every baby that's born could be, another genius or another criminal. It could be Elon Musk or it could be Elon Musk.
On a little bit different note, going back to what are the arguments for a God that is not supernatural, and is God alive?
A God which is not supernatural is not the kind of God that Christianity talks about. I gave a talk like this. I was invited to give the Summerhay lecture at Brigham Young University. And only afterwards, talking to somebody, did I find out that what I was talking about goes definitely in the face of Mormon theology. They've got a vision of God which is very different from mine. That's okay. I don't think that you could have the rich theology we have without a God who is outside of space and time, and yet has existence. Do you call that being alive? What is life? That's the poets can answer that one. But certainly God is not a mass of DNA cells. But God exists. I believe that the thing we use the word angel to describe is a real entity, even though I have no idea quite what it is. We have wonderful poetic ways of describing it, but we're just trying to describe something that our human brain can't get around. And yet, it would be an entity that has intellect and free will and individuality and a relationship with its creator in a way that I don't understand. But that's different from being God.
Thank you. This one's kind of lengthy and it's hard for me to understand, so let's see what you can do with this. Universal harmony suggests that I am. What the universe is, and through time has led to me, as a concept and expression. Does science or religion convey any relativity or knowledge of a coinciding or conceptual celestial, or cosmetic relativity to my existence or human form?
I'll put it in a different way. The fact that you exist cannot be erased. The fact that you exist is a truth that will always remain true. And that you exist as a physical human being means you're in a relationship with other physical human beings. And that will never change. And a God who is big enough to create all of the stuff we're talking about is big enough to be aware of that existence and to be delighted in that existence. But we're also given the freedom to create those relationships or to decide not to create those relationships. And there's a time for everything. It's the great scripture according to the birds. I guess it was actually, who was the guy who actually wrote that? But who turned it into a song, the folk singer from the 40s and 50s. Pete Seeger, thank you. Old age, catches up to me. But there is a time and a relationship to everything. And the wild thing is that we're given the freedom to actually create the universe that we're in terms of the relationships that we have with each other. And what's often referred to as being co-creators with God. God has invited us to take part in this universe, this wonderful playground, this sandbox that we're given. And that's pretty astonishing.
Thank you. And the final question is more personal, involving you. It is, what is a typical day like for you and a typical day like at the Vatican?
So the Vatican is a little area surrounded by Rome, surrounded by a little wall, and I don't live there and I don't work there. I live and work in the Papal Summer Gardens, which is located about 30 kilometers to the south and east in a little village called Castel Gandolfo. And the area of the gardens is actually bigger than the area of the Vatican, but it's extraterritorial. It doesn't count in the square miles of the Vatican. So in theory, the cops can't cross the border to catch me. I tend to, because I'm in Rome, but I have a lot of colleagues in America, I've got this time zone shift that I'm always fighting. So I tend to wake up about 5:30, 6 in the morning, try to get to my office. I have the very exciting job, one of my jobs as being the director of the Observatory. I'm up early, I'm the guy who pulls in the trash cans. Somebody else puts them out at night, I pull them in when they're empty. I'll maybe do a little bit of a walking in the morning, especially if the heat is going to be hot the rest of the day. And we are in these gardens, so I can go for a walk, and it's a marvelous place to sort of contemplate where I'm going, what I'm doing. My first job is generally answering emails. On Mondays, we have a 9 o'clock meeting with the staff, the lay staff, sort of working out what's going to be coming up that week, who are the VIP visitors going to be, are we holding workshops anytime soon, that sort of thing. At 10 o'clock, everything stops. It's the most important moment of the day. And all of the scientists and all of the staff, what do you do as a scientist? Mostly you're staring at a computer screen. You're answering emails, or you're writing an article, or you're analyzing data from the last time you were at the telescope, but it's you in front of your computer screen. At 10 o'clock, that stops, and we all gather in the coffee room where we've got an industrial strength cappuccino machine like you find in an Italian cafe, and a couple of Italians who know how to make the noisy things and the grinding the coffee and the spuma making it. It's marvelous. You have to have been born and raised in Italy to make cappuccino properly. You will not find a proper cappuccino anywhere in America. You will also not find a decent mug of coffee anywhere in Italy. It's a different drink. So you love the one you're with. Usually that's when, if we're having visitors, they usually show up on the 10 o'clock train, so I've gone to fetch them. We have coffee together. And I'll either be doing my writing or I'll be taking care of visitors until 1:15, when the Jesuit community gathers together in our chapel, which is upstairs. I mean, I live directly over my office. so my commute is to walk downstairs. We walk back upstairs, we go into the chapel, we have a noontime prayer together, and then we have the big meal of the day. So there is a woman who cooks for the Jesuit community, and she's a lovely lady. And she prepares the classic, first the pasta dish, then the meat dish, then the salad, then fruit. And wine with every meal, of course. This is Italy. And with all of that food and all of that wine, the next thing is to take a nap. So I'm out till about 5 o'clock. And then I may go for my hour prayer walking in the gardens if the weather's appropriate. By around 6, which is noon in the East Coast and 9 in Tucson in California, that's when I start having telecoms with people back east or people in America, whatever business is going on. At 7 o'clock, the community gets together for Mass, and then we have the other religious ceremony of the day, which is the ceremonial emptying of the dishwasher, because it's been running all afternoon. At which point I may have more telecoms, at 9 o'clock, 10 o'clock, or on a couple of days we'll get together upstairs as a community and have drinks and just talk about what's going on in the world. It's a wonderful life. It's a very relaxing life. It's very productive. It's like I have 2 complete days. I've got the morning when the email is not coming in from America and I can work, and then I've got the evening when I can talk to people in America and do work then. And it's a life that has the sacraments right in the house, really convenient. And I love that. When I was first thinking of being a Jesuit, I asked a good friend of mine, am I crazy? And he says, I can't tell you, I always wanted to do that. I'm going to tell, why don't you talk to my wife? She knows you. So she and I went out to dinner. He was a professor at Stony Brook at the time. We go out to dinner in a little restaurant, and I'm pouring out, what's stopping you from joining? She goes, well, it would be too easy. The life would be too pleasant. I get to have the sacraments all the time. She goes, why is that a bad reason for joining the Jesuits? I guess maybe that means that's really what I'm supposed to do. The end of the story is, after we've had this heart-to-heart, the two of us, she then says, don't look now, but 2 tables over is somebody from Dan's department, and he's been watching the 2 of us all night. Who knows what rumors are going to be going around tomorrow. But that's the general trend of the work. It's both the time when emails show up and the time when we have a chance to be together as a community and to pray together, which at the end of the day is why I became a Jesuit. And if tomorrow they instructed me to, under obedience, to move to the inner city and serve at a soup kitchen, that would be fine. I've done it. I've done the other things. Frankly, that's how I felt when I joined. I joined the Jesuits to be a Jesuit. And the fact that they've given me a job where I get to do all the things I'm good at and I get to avoid doing all the things I'm terrible at is just, I think, one of the miracles that proves the existence of God. Thank you all for coming.
Thank you.